in the beginning of this, I just want to go through a few comments about the responsibilities that you have as an installer. By law, by code, you're required to do a few things. One of them is what we're doing today. You're being certified by this health department that allows you to install septic systems in Davidson County. The other one is you got to pull plumbing permits, and we're going to talk a little bit about that. And the third one is what we're going to do by way of enforcement when you don't follow these requirements, regulations. So installer certification, first question is who needs a certification? If you want to pull a permit from the Codes Administration, a plumbing permit for septic, you need to be certified by our office. And I know there is some issues where the Codes Administration will sometimes, if you are a representative of a certain company, they'll let you pull that permit. But regardless of who pulls the permit, there needs to be somebody on site while there's work going on. There needs to be somebody on site that's been certified by our office. So we like, the people that need to be certified are, if you are pulling the plumbing permit, you need to be certified. If you're going to be the responsible person on site, you need to be certified. How do you get certification? You come to a seminar, either what we're doing today, or when we take these seminars and we provide, we show the tapes on the second Tuesday of every month. So you can either come then or come to one of our live seminars. You have to make an 80% or better on an exam. That's conventional if you're just going to do the conventional, and also the LPP if you're doing both. And also, in order to pull a permit, Codes Administration is going to ask you to be licensed through them. So after you get certification from us, you're going to have to talk to them about licensure. A little bit on plumbing permits. There's been some confusion over the years about when do you need to pull a plumbing permit for septic. The rule of thumb that we like to tell people is if you're digging into a septic system, you probably need a plumbing permit. There are a few exceptions. If you're, of course, if you're going to dig up a septic tank to get to the access port and pump it, you don't need a permit as long as it's being pumped by a licensed pumper. If you need to extend a switch box or install a riser for a septic tank or pump tank, we don't need a permit for that. If you replace a pump, there's not a requirement to get a permit or any approval from us, provided that the pump is an in-kind replacement. In other words, it's the same exact pump, you're just replacing it. If you install a new pump that's a little bit larger, a little bit smaller, it's going to affect the way that system operates. So in-kind replacement of a pump is acceptable without permit, but any other, anything else with a pump, you need to talk to us. If you need to snake out or jet out a tight line to unclog it, we don't require plumbing permits for that. Good rule of thumb is anytime you do anything with septic system, you need to have a plumbing permit. If you're confused about it, call us and we'll talk to you through it and we'll advise you on whether you need a permit for that or not. We don't mind. We take phone calls all day, every day, so call us and let us know or ask us questions. Enforcement. There's been some, there's been illegal activity with septic systems. And to be fair to everyone, for you all that are here and going through this seminar and pulling permits, it's unfair for you to be doing all that, following the law, following the codes, and somebody else getting away with not being certified, not having to pull permits and things like that. So we're ramping up a little bit on our enforcement. just to make it a level playing field for everybody. Everybody follows the codes just like you all are, and it makes it a fair, level playing field for everybody. But the ways that we can enforce, there's several things that we can do depending on the intensity or the criticalness of the violation. Of course, we can place you on a probationary period, which basically means that if you violate one more time, we can remove your certification. We can put you on a suspension where you're not going to be able to pull a permit for a certain period of time. And we can also revoke certification, which usually revocation means that you don't ever get certified again, or it might be there might be some hoops that we make you jump through before we offer up certification again. Also, for all of those that don't have certification, so if you're not a certified, you're not pulling permits, and you're not licensed by codes, we also have the authority to write a court citation, which would cite you, that you'd have to show up to court, and the judge would rule on the violation, innocent, guilty, things of that nature. It's just like a regular court of law. And it's really important to realize that once we send you to court, once we cite you to court, it's out of our hands. It's largely out of our hands. It's up to that judge to make a decision. So he can charge fines, he can charge court costs, and he can even sentence jail time. So if it gets to the seriousness of we have to issue a court citation, we don't like doing that, but if we have to, it's largely out of our hands. It's in the judge's hands. He does what he wants to do.
My name is Scott Felwalk. I'm the staff soil scientist, and I don't get to interact with y'all quite as much as these guys do, mainly because when I see a piece of property, this is the state that it's in, I will go out, review it, do a preliminary first off to see what's good, what's bad, where we suggest having a surveyor establish this 50-foot grid system of stakes. This is that grid that y'all are always having to cuss to have to work around, but these guys are going to hit on that somewhat as well. As y'all know, when you see the recommendation drawings, those stakes figure pretty prominently. So we ask that they remain as much as they can. Realize that y'all have to work around them and try to reestablish them as best you can, or don't interfere with them at first. But this grid is what we use as a baseline for ground control. So we know where we're at, and we can convey to you where we want that system put in. I go out and make observations at these points or in between them, and use those observations to come up with a soils map. If you go to the next one, please. And this is a copy of the soils map, which really what y'all are interested in, that MPI rating, that number, that's what tells the environmentalist how many square feet per bedroom to put in. And also the other important number up here is this restriction. You notice these at 36, of both of these, there's no restricted trench depth. Now, sometimes that'll change. That'll be reflected on their recommendation drawing. The reason for that importance, we've got different horizons that come in, or sometimes, as you well know, a case of shallow depths of rock. And because of that, we want to maintain that buffer zone between either like a fragipan layer, or restrictive clay, or that rock. And that's why that restricted trench depth is so important. But I'll reflect that on my map, and then they will convey that on their recommendation drawing as well. You can go to the next slide. So this is a drawing that they came up with from that map that I formulated. And they'll get into that in more detail with you all, and this is what you're probably used to seeing when you go to codes to pick up. This tells you where to put your system, somewhere else on there to tell you how many square feet per bedroom and all that to lay out. But it's got, sometimes it'll have the features that I show, such as drainage, gullies, cut banks, those sorts of things. They'll actually show them on their recommendation drawing as well. But it was critical to note, all of these grid points hopefully will still be up in the field as well. When they get knocked down, like I said, they're going to hit on that a little bit harder than I will. But in a nutshell, this is what you'll be seeing from my map. You can go to the next slide, please. Now, the two times that I run into you guys are when Sometimes I'll formulate a map, and you can tell this is in a rocky formation. I think this happens to be along the Highland Rim and the Bellevue area, some of those ridges, and a lot of times up in Jolt we run into this as well. We've got really fragmented rock. In order for me to make my soils map, if I can't get this little hand auger you see down, that's a beautiful device, but like this last summer when it was so dry, you can't get that thing down. So number of times, in fact probably half the maps I'm making now, if I can't get those down, we can't afford equipment here at the health department because we're government. So what I ask the property owner to do is to dig me some what I call backhoe pits. Sometimes they'll dig 12-inch worm auger holes for me, but I really prefer to see pits for the simple fact that it gives you a lot better read on what you're seeing. Go ahead and advance the next slide, please. And this is a cut that was excavated. I think this is a road cut that I used. But as you can see, some of this larger fragments of chert, there's no way you're going to get through that with a hand auger. So when we get asked for those pits, generally it'll be on a final map area where I'll send them a form sheet. How many of y'all in here have dug observation pits for me before? Quite a few of you. When that comes, if there's any questions at all, and I've got that noted on that information sheet that I mail out to them, call me and ask me. But I'll either have them flagged in the field in a different color, because these guys usually mark like boundaries in orange or something. We've got different colored flagging. I'll say to give me the holes at the lime colored flagging or blue or something different than what they've got out there in the field, or at certain grid points. And when we ask for those in the grid points, we send them a form letter telling them not to interfere with the grid stakes. When I'm saying a grid stake A5, I don't mean to pull up grid stake A5, dig a 4-foot hole and then put it right down the middle, just in that approximate area. And that's another thing about those grid points. You don't want to interfere with them, as I said before, and these guys are going to hit on as well. But we're talking about a 4-foot deep hole dug along contours, and the importance of that is, if you dig because I don't want it to be a 20-foot long trench, just basically I got to see down to 4 feet at a point and taper them back to nothing. So make it as small a hole to impact the area as little as possible, but dig it 4 foot to a point, taper back to nothing along contours, so that when they go back, these guys, the environmentalists, are going to bark at me for getting holes all over their area. But it'll impact the least if that's dug along contours, because if you dig them up and down slope, when you go to lay out your lines, if you've got those pits kind of cross connecting there, they're going to have a problem with that. So if you would please do that, that'll help me out immensely. So that's one of the times we're gonna interact there, is when we've got that situation and I need some backhoe pits dug. Another one is, say we've got the recommendation, you guys go out there to put the system in and you're digging along. Go ahead and get one more slide, I think. Yeah. And you run into this. You have a problem getting a hole down. Now, I'm human. I've made a mistake before. It was back in the 70s. No, it's a few times since then. But if you have a problem getting a hole down, it could be that you're running into a certain layer of rock that we didn't observe when we made the map. Doesn't mean that it's, we can't work around it. Call us and we'll be glad. I'll be happy to meet you out here on site as well, the environmentalists that signed the recommendation, and we'll see what we can work on. Sometimes we can hop over just a little bit, or you may be able to bust through that rock. The thing is about a lot of this chert and limestone up on the rim, you can get through it pretty easily. Now when you get down around the lake, what we call the Carter's Formation of limestone, that massive stuff, it takes a jackhammer, as y'all well know. Not fun stuff to dig through. So go ahead and cycle through one more. That's a standard pit. This is the hill sloping down here, and that's 4 foot at a point, and then tapered back to nothing. And that's the face that I used to review it. So that's what the backhoe pit will look at. So basically those 2 times is when you have run into problems as far as installing a system, and we have problems getting down, that we can come out and provide some technical assistance, or when we need some observation pits.
The next portion of this seminar is going to be the use of the scale, which we emphasize it very heavily on the exam. If you don't know the use of the scale, you will fail the exam. It's very important that you're able to take one of our drawings and place that in the field the way we need it to be placed. So the use of the scale is very important. It is a very simple concept once you grasp it. But if you haven't grasped it yet, it's very, very difficult, very confusing. The scale is very confusing to a lot of good men. So what we want to do is I want to go through it, and I don't want you to even start that exam until you feel comfortable that you understand the scale. Because again, if you don't understand it, there's a portion of the test that deals a lot of points for the scale. If you don't understand the scale, you will fail the test. So I just want to go through that, a few things about scale. When you get a drawing, when you go pull a permit, a plumbing permit from codes, they're going to hand you a drawing, and it should be to scale. Almost every drawing that we issue is going to be to scale. There's very, 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 very few exceptions. And I really can't think of any right now, but so it should be to scale. If it's copied or faxed or scanned or anything done electronically to it, it could distort that scale. And that's important because if it distorts that scale, you could be laying out system in an area that we don't want you to lay it out because the scale's off. And in order to ensure that you're getting a good copy, we make all of our drawings with color on them. Now again, there's a couple of exceptions, but almost every drawing that we issue is going to have different colors on it, just for the simple fact that you can tell whether it's a copy or not. If it's got color on it, it's likely that it's an original. If you don't see a color copy, or if you think that the scale might have been distorted for some reason, give us a call. We can easily produce another one for you. We can make another copy for you that's a good copy. But onto the scale, there's two different types of scales, and they're interrelated. The first scale is what we call the drawing scale, and it's on a drawing, and hopefully you've got a copy of this. But in the bottom middle it says scale, 1 inch and 100 feet. That is your drawing scale. There's another type of scale, which looks like a little ruler, is an engineer scale. So when I say drawing scale, that's the scale that's on the drawing. When I say engineer scale, that's the scale on the little ruler. So when you're looking at drawing scales, the typical scales that we use, 1 inch equal 20 feet, 1 inch equal 30 feet, 1 inch equal 50, and 1 inch equal 100. The majority of the time we're either going to use 1 in 100 or 1 in 50. Occasionally we have to use some of the tighter scales. But it just means that 1 inch on the drawing is equal to 20 feet in the field. So a line 1 inch long on your drawing is going to be a line 20 feet in the field if your drawing scale is 1 in 20. Same thing with 1 in 30. 1 inch on your drawing is going to be 30 feet, a line 30 feet long in the field. And 1 in 50. 1 inch on the drawing is 50 feet in the field. 1 inch and 100, 1 inch on the drawing is 50 feet laid out in the field. Okay, next slide. So here's an engineer scale, and it has the ones that we hand you, and the typical engineer scale is going to have a 10, a 20, a 30, and a 50. So, okay, go to the next slide. As you can see on the 10 scale, over there on the left, 1 inch, there's going to be 10 little tick marks. So that 1 inch is divided up into 10 equal divisions. The 20 scale, that same inch is divided up into 20 divisions, 20 little tick marks. Okay, next slide. Same thing with the 30. The 30 scale, on the engineer scale, 1 inch has got 30 little tick marks. And then the 50 is the same. 1 inch, 50 little tick marks. Next slide. So, the easy way to remember it, if your drawing says 1 in 50, use the scale that's 50, the 50 scale. Your drawing says 50, Your engineer scale, use the 50 scale, and every little mark you see is going to be 1 foot. Okay, so 50, 50, 1 foot. Next slide. Oh, too long. Go back one. There you go. The 30 scale. If your drawing says 1 in 30, use the 30 scale on your engineering scale. Okay, and every little mark on that scale is 1 foot. Next slide. Same thing with the 20 scale. If your drawing says 1 in 20, use the 20 scale. Every little mark is 1 foot. Next slide. This is where it gets kind of crazy. When you see 1 in 100 on your drawing, which most of our drawings are 1 in 100, if you see 1 in 100, use the 10 scale. And then each tick mark, each little line on there is going to be 10 feet. Not 1 feet, not 1 foot, but 10 feet. So if you see 1 in 100 on your drawing, use the 10 scale. Each mark is 10 feet. All right, next slide. So you've got a practice sheet. Hopefully, if you don't, raise your hand. I'm going to have some of the guys walk around, and we're just going to practice this a little bit. And before I get done today, I want you to be really comfortable with the scale so that you can do well on the test. So get your drawing, get your engineer scale, and we're going to look at this little box up at the right-hand corner. So the scale in this box is 1 in 50. So we're going to take our 50 scale on the engineer scale. We're going to use the 50 because the drawing scale is 1 in 50. We're going to use the 50 scale on the engineer scale. And then every single little mark is 1 foot. It's 1 foot. So you just got to... Yeah, it messes up the camera. So that scale example line A, using our 50 scale on our engineer scale, comes out to be about 132, 133. 132 and a half. That's good, Ron. So try to look at that line A. See if you can see where I got 132. And if you've completed that one, look at scale example line B. Still using the 50 scale on our engineer scale. I get about 176. Make sure you see where I get that. 176 on line B. Don't be afraid to ask questions. It's a confusing issue. Line C in that box is about 67 feet. So we got line A, 132, line B, 176, line C is 67. Does everybody see where we got that? Okay. Now if we go to the main portion of this drawing, if you look down at the bottom middle of the page, it says scale is 1 inch equal 100 feet. So again, we're going to use the 10 scale. So we got a 1 in 100 on the drawing. Use a 10 scale on your engineer scale. And let's try line D. Big blue line up kind of in the middle of the page to the left. Again, each mark on your 10 scale will be 10 feet. I've got about 288 feet. .288, 289, 287, somewhere around there. You kind of have to estimate in between marks. Has anybody got anything different? Which one? Line D? D. It's kind of if you look down the page, it's kind of in the middle, over to the left, kind of. Line D is in dog. Any questions at all?
Today, I'm going to be talking about septic tanks, pump tanks, and soil improvement practices. And what I'm going to talk about, I'm going to go over some of our requirements, our regulations, and also some of our recommendations for these components of a septic system. All right, septic tanks. Septic tanks, we want a one-piece, two-compartment design. I think years ago they used to use a two-piece tanks. We don't accept those anymore. I hadn't seen one of those in many moons ago because those leak. I never saw one that didn't leak. So we want a one-piece, two-compartment design, two access ports, and also it must be watertight. And also, I'm going to talk about some of the problems we've had over the last couple of years since our last seminar with these components of the septic system as well. The tank has to be watertight, and we'll talk about it in a minute. You got to fill it up with water up to the invert of the outlet to check for leaking. And I've found some tanks in the last couple of years that still leak, so we're still having those problems. Polyethylene septic tanks may be installed prior to approval. This typical plastic septic tank, if you want to use one, you need to give us a call and let us know you're going to use one. You can use, the advantage of using a plastic tank, if you got a site with a bunch of rock and you're having a hard time getting it in, that's going to be the advantage to use a plastic tank. But like I said, we do accept them, but we want you to give us a call before you install it. All right, when you go to set your septic tank, these are some of the things we recommend. A 2-inch gravel base under the tank. If you're in a situation where you have to pull a lot of rock out of the tank hole, recommend that you install a 4-inch gravel base under the tank. And there's no variation of levelness allowed toward the inlet of the tank. As we all know, stuff don't go uphill. So no zero going that way. I think tanks naturally manufactured, they got an inch. The outlet is an inch lower than the inlet side of the septic tank. So if you get the tank off, you're gonna be going uphill kinda. But maximum variation not to exceed 2 inches going the other direction. If you got your septic tank going downhill, for every inch it's going downhill, that's it. You eliminating the storage capacity of the septic tank. So 2 inches going that way and 0 going the other way. And a lot of installers forget about this. Before you go to lay your system out and dig your tank, you need to be very leery of this. And Chris is going to go over it also when he talks about conventional systems. But we need that 4 inches of fall from your outlet pipe on your septic tank to your top of your first crossover. In the years past, a lot of guys would just completely forget about that. And that's all. And that also goes with your baffle box also when you got a pump system. The outlet on that baffle box needs to be 4 inches higher than the one on top of your crossover in your septic system. Like I said, Chris is going to kind of stress that also as well. But we hadn't ran into that many problems too much. I've had situations where we had to actually chisel out some of the around the T-fitting to lower or move it up and move it down to get it to work. Your access ports, we want 20-inch minimum openings. Your port can be no deeper and your inlet side than 24 inches. And on your outlet port of your tanks, we want it to be 6 inches above grade for the sake of now we're requiring filters for the sake of maintenance on that filter. So for every septic, it used to be just a pump, but it's the septic tank now. The outlet side of that septic tank needs to be 6 inches above grade. And risers, same 20-inch minimum diameter. And like I said before, the outlet port must be 6 inches above grade. And there's just a picture of, and also if you dig your tank deep, you can use sidewalls risers to bring it up to get it 6 inches above grade. T-fittings, we want a 4-inch scheduled PVC. It must be located directly under the access port, and it must extend 12 inches below the liquid level. And an effluent filter must be installed on the outlet T of that septic tank. On your effluent filters, it can be holes or slots. The filtration must be 1/16 inch. And the filter handle must be within 24 inches of the riser cap. So some homeowner can come in and take it out and do general maintenance on it to wash it out. And there's a schematic of your septic tank. And also something I want to say right here, I've had this happen a couple times over the years. When you go to install your T's, they need to be installed as shown. I've had situations where people have installed these at an angle like this. So we want you to install them just like this, as shown on this diagram right here. Go ahead, next slide. Tank connection. The inlet and outlet pipe seals must be silicone caulk or hydraulic cement. If you use, some tanks use a rubber sleeve. If you use those tanks that use rubber sleeves, you need to secure it with a metal worm screw band. Prior to inspection, you need to fill your tank with clear water to the invert of the outlet pipe 24 hours prior to you calling your inspection. And secure the lids when filled. Now, this is something I guess when we first started requiring these septic tanks to be filled with water, and I kind of told the guys I had a nightmare. When we first established it, I was doing an inspection, I went and looked in it, there was a little kid in there. It scared me to death. And so I guess that was a big component of, you need to secure your lids. When you fill that tank up with water, secure your lids with like maybe two screws on each inlet, on each access port. Go ahead. Prior to your inspection, do not backfill the tank. Still having problems with this. You need to leave us enough room on the side walls of that tank so we can check to make sure that tank is not leaking. So I've had some problems the last couple of years of installers still doing that. So always be conscious of that when you're digging your tank hole. Dig it big enough so we can look to check to make sure that that tank is not leaking. And also on repair systems, when you're doing a repair system and you put a new septic tank in, you need to plug it off so no sewage can get in the tank. Now after we do the inspection and after the approval, you need to unscrew those lids on the inlet side of the tank before you cover it up. But the outlet side lids, you need to remain secure, because if you screw them down and we got to dig it up on the outlet side, we may not never get it off. We had to cut it off. But the inlet side needs to be screwed down, because nobody needs to be open it, because it's going to be 6 inches above grade, so nobody can come in and open up and look inside the tank and possibly fall in there. Pump tanks. Any questions on septic tanks? Pump tanks. One piece, one compartment design, 2 access ports, just like your septic tank, watertight, just like your septic tank as well. Same for your setting your pump tank, same for your septic tank. We recommend that if you a 2-inch gravel base on your tank, 4-inch gravel base where when you're digging your tank hole, you got to move a lot of rock out of there. Use 4 inches. Same thing, no variation of levelness allowed toward the inlet of the tank. 2-inch maximum going the other way, going downhill of the tank. Pump tanks, you want a 4-inch schedule for the 4-inch schedule for the PVC fitting must be installed on the inlet side of that tank. So on the inlet side of your septic tank, you need to install that T-fitting on the inlet side of your tank. And it's just like your septic tank, they need to extend it 12 inches below your liquid level. And also you must install a riser above the pump access port. And also, just like on the septic tank, 6 inches above grade with that riser, so we can get in and do maintenance on the pump and replace it as needed, if needed. Same as the septic tank, inlet and outlet must be sealed with silicone or hydraulic cement, and the rubber sleeve, if you use a rubber sleeve, secure with a metal worm screw band. Now this is a typical pump installed. You need to set your floats accordingly. Pump on, pump off. Now this right here would be given on your plans, and the tether length of the floats would be directly associated with the daily dose that we're going to set on our plans. We might have you to set it to 6 inches, 8 inches, 6 to 8 inches. It'll be on your plans, but the tether length on that float is going to be directly related with that. And you set your high water line 2 inches above that is what has shown. And your pump off setting, that pump needs to stay submerged at all times. So you set your floats accordingly and on an 8-inch block. Oh yeah, that's it. Okay, we want a threaded coupler on the outlet pipe. Check valves. Only install a check valve when specified. We're still having problems with guys installing check valves. A lot of people just put one on there, but you only need a check valve. I just did a design on the system. It's got a 950 feet tight line. That's going to require a check valve because the storage capacity in that pipe, is going to come back if you put a check valve on it. So, but most of the time you're not going to need a check valve, but if you need one, it'll be indicated on the plans. Only put one if it's indicated on plans, because if you put one on there, and if it's not needed, all it's going to do is wear out, and then you'll be back out there in a year or so to replace it. So always pay attention to the plan. And sometimes when you're pumping, you might be pumping downhill, like on the LPP system. You need to install an anti-siphon hole as specified on your plans as well. And there's your typical schematic of your pump tank, and you got your T-fitting on the inlet side of that tank and your floats. high water alarm. The high water alarm needs to be located within 25 feet of the residence. It needs to be installed somewhere where it can be heard. That's where it needs to be installed. It must be mounted on a 4x4 post, a separate circuit from the pump, and it must meet all current codes. And Metro Codes Administration must inspect the electrical on that pump, the high water alarm. Setbacks for septic tanks and pump tanks. And like Scotty mentioned early that he said he's human, he makes mistakes. I think he said he hadn't made one since the 70s. But we make mistakes as well. And so we need y'all to kind of help us out. That's why I'm going over these setback requirements. When you to go to study, because we might miss a well or a cut bank when we out in the field doing our designs or whatever, and if you notice it, don't put it where we saying to put a system at or whatever. Always be know that, just help us out as well. But all wells, we want your septic tanks and pump tanks got to be 50 feet from your well, from wells. Now, if it's properly capped, it's 25 feet. But if somebody tell you, well, we ain't used that well in 50 years, and they just kind of just put something over it, that's not properly capped. It has to be properly abandoned by a certified well driller in the state of Tennessee. Your residence, dwellings, 10 feet if it's a crawl space. Septic tank, pump tank must be 10 feet if it's a crawl space, 15 feet if it's a basement residence. Water line, 10 feet. Curtain drains, cut banks and drains, 25 feet. Property lines, 15 feet. I had a guy install a septic tank 5 feet off a property line, and of course he had to move it. And so, but that was my first situation I've seen like that. He just installed it. I guess he didn't think it was a part of, his mind was just focused on the disposal field 15 feet off of the, because I know on our drawings, we don't put the septic tank location on our drawings. So that's why you need to know these required setbacks when you go to pick out your tank location. 15 feet off their property line and 25 feet from cut banks and drains. So if we get out there and if it's not, we're going to red tag it and you're going to move that tank. So always remember these setbacks. Questions? Septic tanks. Questions on pump tanks, rather.
Poly tanks, do y'all have a list of approved poly tanks or just be case by case?
Yeah, is there a set standard, Chris, I think we have for plastic tanks?
The state has a list certified for all the tank manufacturers that will be used.
Jesse, could you repeat all that?
Yes.
For the camera?
His question was, do we have a list for the plastic septic tanks of the requirements that they can use, the standards of them? And Chris said, the state has a list of standards and requirements for the plastic tanks. So I guess it's the manufacturer, whoever you're going to buy it from, can meet those requirements. You can buy it from them. But if you want to use one, give us prior approval. Not approval. Give us, call us and tell us you want to use one before instead of just putting it in there. More questions? All right. Soil improvement practices. Now here's a change we made. The state has made. There's no more curtain drains. As far as the verbiage, they have renamed it to an interceptor drain. And I'm going to try to remember to use that term the whole time I'm talking to you. It's called an interceptor drain now. So when y'all got to remember that, because when y'all take this test, it's going to be interceptor drain, and on the test, and on our plans also as well. And I'm going to talk interceptor drains, drawdown drains, and surface diversion ditches, surface water diversion ditches. Interceptor and drawdown drains. It must be at the prescribed width and depth as shown on our plans. And the depth of the curtain drains is going to be a minimum. We might say it might need to be a minimum of 36 inches, 40 inches, but they'll be on the plans. Slope requirements, minimum 5 inches per 100 feet. And the slope must be consistent. Now, if I have situations where I'll go to inspect the curtain drains and there's a big flat spot in it, it just flat as a pancake. And I've heard this several times from installers. Well, that water push it over. Well, we want consistent slope on that curtain drain all the way down. If I inspect it, every time I should be consistently going downhill. So always remember that. No flat spots at all in your curtain drain. You might get in there and rake that ditch to get it smooth, but no flat spots whatsoever. Also, requires 2 inspections. Curtain drains require 2 inspections. First inspections, well, I said it again, interceptor drains. Forgive me. They require 2 inspections. One inspection, the first inspection is with the plastic in the pipe, and then the second inspection is when you rock it. And I want to say this also right here, that you can be installing your septic, the disposal field during the inspection process, but I've had times where an installer call and he has all of them done at one time, you know, overflow and curtain drain. That's fine, but you know, we prefer that you put the curtain drain in first, but you can be working on overflow at the time, and we do it in that scenario because we might be so busy trying to run and get these inspections when peak season starts. Okay, drain liner if required. Now also, there may be some situations where we may not require any plastic in the interceptor drain. So they'll be specified on the plans whether or not we're going to require plastic. And there also may be some situations where we'll just require plastic on the top side, the left or right side, or bottom, whatever side. But we'll specify, so you must pay attention to all these plans, especially when it comes to the curtain drains. But if the plastic is required, it's black plastic, 6 mil thickness, covers the bottom of the trench and extends onto ground surface, not required beyond the point of departure. From the point of departure out to the outlet, no plastic is required if required on our plans for this particular curtain drain, if it's required. That's just a picture of the plastic, how to install it. Go ahead, Spencer. Now this is a side view of the curtain drain. That berm, the earth berm, 6 to 8 inches. Now there's going to be situations where we may not require that berm now on these interceptor drains. So we'll specify on the plan if it's required or not. And as far as your rock is concerned, you can use the same size rock of your overflow system, but no bigger than 2.5 inches. And you got a 4-inch ABS corrugated slotted pipe, and you can secure that pipe in the middle of the ditch with gutter nails if you want to. At the end of your curtain drain, to install an animal guard. And your last 10 feet of your interceptor drain is a 4-inch PVC pipe with a 1/2-inch steel animal guard installed as shown. And that's just a drawing of how the last 10 feet of your drain will look. And that's just showing the connection, when you make the connection with your PVC from your ABS pipe. Drawdown drains. Same requirements as interceptor drains, but there's no plastic required. No drawdown drain requires any plastic because you're trying to catch the water from both sides. as opposed to trying to protect one side of the disposal field. But like I said, I can't keep stressing more, you gotta read those plans. The plans will guide you what's required, and when what's required. Surface water diversion ditches. Now these ditches, no rock or pipe is required, but the same slope requirements, 5 inches per 100 feet minimum. It must be installed where prescribed. And there's a picture of detail of a surface water diversion ditch, 6 inches, 6 to 8 inches berm, 6 inches deep. "25 feet from the disposal field. Dwellings, water lines must not interfere with the operation of the ditch." I know a lot of people call me and say, well, how far can I be off to the house with that curtain drain? Well, and I've talked to Scott about it and talked to the guys, and as long as it don't interfere with the operation of it, I would try to stay 10, 15 feet off of it if possible, but it does not need to interfere with the operation of that curtain drain. Pay attention to all specifications. Any questions? Yes.
I had a homeowner want to book his downspouts for the curtain drain. I told him he could do whatever he wanted there if we left inspected.
No, he don't need to do that. He would need to do that.
Can you repeat the question?
Oh, he said he had a homeowner who wanted to hook his downspouts to his curtain drain, and I told him no, he don't need to do that. It might affect the operation of the septic system.
Okay, on to conventional large diameter gravelless pipe soil absorption systems. My name's Christopher Mickey. I know most of you in the room. These are what we commonly refer to as the non-alternative soil absorption fields. Conventional and large diameter gravelless pipe, otherwise known as LDGP, are your two most common. We're seeing what I refer to as the others. There are other systems that have been approved by the state. These include the chamber system and the easy flow. Mr. Scott Loft, our department, is going to discuss the chamber systems after me. Go back. The difference between the conventional and the large diameter gravelless pipe. A conventional trench is dug using a 3-foot wide bucket, whereas a large diameter is dug using a 2-foot wide bucket. Therefore, when you're installing these systems, to maintain a 6 feet required distance in between trench walls, you can install the conventional system on 9-foot centers and an LDGP on 8-foot centers. Therefore, you're actually able to save room by installing a large diameter gravelless pipe. That's probably one of the #1 reasons why it's used. The second reason that it's used is because no rock is required. It's easier to install. Rock's always going to be required on a conventional system. However, hence the name large diameter gravelless pipe, it does not require rock. However, in some soil types, we do require sand. It will always be specified on the plans whether or not sand is going to be required. On the conventional systems, a grade board is required to keep the pipe up off of the trench bottom unless you use a manufactured rock slide. Gentlemen, this is a rock slide that you buy. This is not one that you make using 2x4s and chicken wire. I'm impressed by your ingenuity. I am sure that it works. However, we've got to draw the line someplace, and we've drawn it. Large diameter gravelless pipes, they will require inspection ports. If you do not know what that is, we'll go over it later in the slide. Large diameter gravelless pipes, usually, and I say usually, more than likely they will not be required on repairs. The reason for this is when we do repairs, we do not obtain soils analysis. We do not know if it's a higher clay content soil, therefore we will not be allowing the large diameter gravelless pipe. We will be requiring conventional systems. However, if we do have soil information and it is favorable soil, more than likely we would allow large diameter gravelless pipe. Before you ever even think about installing a system, very first thing y'all need to do is lay out the system. Visit the site. Hopefully all the grid stakes are still going to be up and they're going to be legible. If they are not, tell the homeowner that they need to be reestablished by a registered land surveyor or call me up. If you don't want to play the heavy, I'll be more than happy to. If I get out there to inspect the system and I see that the grid stakes aren't up or I have problems reading them, I'm going to tell you to get a surveyor out there. Therefore, there's no reason for you to have to work under those conditions. We want to make sure that this system is installed correctly and in the area. Second step, after you visited the site, the grid stakes are up, you can read them, go ahead and mark area 1 in the field. The trenches are to be laid out within the boundaries of area 1 and on contour. Do not extend that trench past area 1. Usually the extents of area 1, area 2 are not designated by me, but they're designated by the soil map, which in turn is drawn up by the soil scientist. That line's there for a reason, not just my whim. Usually it's because I got to maintain a certain buffer off of a natural condition out there, or that's where acceptable soil ends. These are the buffers that you got to maintain from the disposal field. This is something that once we draw up the plan, everything should be already taken out. However, it is important that you do know these. More times than not, when we do repairs, we're working without a soil grid in place. We're working without soil evaluation. Therefore, it's more likely that we may miss something. Therefore, if you run across something that you think we missed, and we're prone to mistakes just like you guys are, please feel free to call us up and make sure that nobody's made a mistake. Because if we made a mistake and we catch it on the back end, guys, you're still going to be responsible for fixing it, okay? Water supply. Water supply means well. Jesse's already talked to you about open versus closed wells. 50 feet is off of an open well, okay? That's every component of the sewage disposal system needs to be 50 feet off of it. If it's been closed properly by a well driller, they got record of it with the state, we can knock that down to 25. But throwing a piece of sheet metal over it and putting a tower with a rock on top of it is not properly closed. Dwellings, 10 feet. Property lines were different from the state. The state requires a 10-foot buffer off of property lines. Here in Metro, we want you 15 feet off of the property lines. Now, that rule, you will see some plans where we've asked for a variance from Metro and we've gotten it to where you can actually become within 10 feet of the property line. However, it will be designated on the plan. Again, if you got a question, call us up. Guys, I'd much rather answer a question over the telephone that takes 15 minutes as opposed to trying to figure out how to fix a mess up that's going to take a day and a half to fix. Okay? Gullies, ravines, dry stream beds. We want you 25 feet off of them. Water line, 10 feet. House to tank connections, 10 feet. And we want you 5 feet off of the septic tank. That means you got to at least have a 5-foot tight line in there. The way this PowerPoint has been set up, I'm talking about both systems at first. I want to talk about what both systems kind of got in common with each other, and then I'm going to split it up and talk about what each system doesn't have in common. Right now we're going to talk about how the trenches are dug. When you dig these trenches, do not exceed 100 feet in length unless you have prior approval from the health department. The state regulations gives us the power that when the situation dictates, we can go over 100 feet. But that reason's got to be good. It can't be because I don't want to put in a 30-foot trench at the bottom, therefore I want 3 110-foot trenches. That's not a good reason. A good reason is going to be the contours were more complex than what we had figured. I'm only able to get in some longer trenches. Can I do it? The answer is going to be yes. But keep it under 120 feet in length and make sure that your elevation difference on that trench does not exceed the per 100 foot length. We'll talk about this a little bit later, but every trench, you're either given 2 inches per 100 feet or 4 inches per 100 feet. You're still going to be required to maintain that 2 or 4 inch elevation difference. It's not going to go up because your trench length is increased. Therefore, just to repeat myself, do not call me up just because you want to be lazy and install less trenches. But if you got a viable reason out there to put in longer trenches, the house site has moved. He's actually gotten inside area 1. I can't work with this. That's a good reason. They dropped all their dirt spoils in my area. I need to put in longer trenches. Those are good reasons, guys. So call me up if you got it. Trench depth and variation will be dictated on the plans. It's nothing you need to worry about. Again, the trench depth, what I'm talking about is every trench that you're going to look at here in Davidson County, you're going to have a 24 minimum, 24 maximum digging depth, a 24 minimum, 30-inch maximum digging depth, or a 24 minimum, 36-inch digging depth. Now the 24 to 24, you're going to have 2-inch elevation difference per 100 feet. That's per 100 feet. Therefore, if you have a 50-foot long trench, how much elevation difference do you have? Answer me. 1 inch. 1 inch. The 24 to 30, 24 to 36, you got a 4-inch elevation difference per 100 feet. Therefore, if you have a 50-foot long trench, you've got 2 inches per 2-inch elevation difference across that trench, not the 4. Trench depth. We measure it from the center of the trench. Therefore, it's in y'all's best interest to measure it from the center of the trench also. Now, if we're on fairly level ground, whether you measure it from the high side or the low side, probably it's not going to amount to that much difference. However, if we're installing on the side of the hill, which is becoming more increasingly popular these days, it's going to be a big difference from measuring on the high side and the low side. If we're going to have a problem, it's going to be because we measured from the middle. Therefore, y'all should measure from the middle of the trench. Crossovers in Davidson County. Our crossovers are to be constructed using 4-inch Schedule 40 PVC pipe. My understanding is the state finally saw the light on this and it started requiring the same thing. However, in Davidson County, we're still a little bit different in that we want the crossover to come 10 feet from the end of the top trench. What I'm talking about, guys, this being your top trench, 10 feet over, come down with your crossover. Now when you're coming into your lower trench, you do not have to be 10 feet. It can be a foot, it can be 2 foot, it can be 30 feet. There is no rule about when you stub into a trench. It's just when you come out of it, we want you to be 10 feet. Again, when you stub out of trench number 2, we want you to be 10 feet off of it. When you come into your lower trench, there is no set rule in place. The reason we want you to be 10 feet off of it, and this may help you to understand our thinking behind it, if solids should ever get into that trench, they're going to be able to work their way down the trench inside that black ABS pipe. They will start settling at the end of the trench. If your crossover is at the end of that trench, you're going to stop up your crossover. By installing it 10 feet off the end, we figured we had just bought ourselves 10 feet worth of time for those solids to actually build up before it actually ever stops up that first crossover. Therefore, using that logic, guys, we're only really interested in what that stubbing out of that top trench. The solids spilling over into that second trench or third trench, it's not going to stop up that crossover that's coming into it. So just remember, 10 feet when you're stubbing out of it. Again, crossovers, Davidson County, we want them constructed out of 4-inch Schedule 40 PVC. We want them affixed using worm screw bands, okay? If you want to put duct tape over that worm screw band, that's fine with me. However, do not just use duct tape. You're to use those worm screw bands, make sure they're nice and tight. We will come out of there, see if we can pop it out with our foot. The reason we want them good and tight is so they don't pop out of you when you're backfilling the system. Makes it a little bit easier for y'all. No 90-degree fittings are allowed on crossovers. Straight. Simple, no 90-degree fittings. Street 45 degrees are not allowed on the upper side of the crossover. However, you can use them on the lower side of the crossover. The reason for this is crossovers, when they're constructed, they need to be located 4 inches off the black pipe. Okay? I got a nice little slide a little bit later on. To get that 4 inches, you have got to provide yourself with a short section of PVC pipe to actually lift that elbow off of it. You will not be able to do that with the Street 45. If you put a Street 45 on the upper side, you will not get your 4 inches of elevation. However, on the lower side, there is no required elevation difference. You can use a Street 45 in it, and on certain slopes, if you're on a steep enough hill, you can stub right into that trench without even having to put on an elbow. Of course, it's going to be a pretty steep slope for that to happen. Here's where we break it up. This information is concerning conventional systems only. The trench width, 3 feet. Must be located on 9-foot centers with 6 feet between the trench walls. Okay? Therefore, it's going to take more room to install this than it is the large diameter. But you got a 3-foot wide trench, you got 6 feet in between the trench walls of it, and therefore it's going to be 9-foot centers. Recirculating systems. We don't have a problem with recirculating systems, guys. Really, we don't. However, the way that Metro code is written, recirculating systems can only be installed in an area where the elevation does not exceed 4 inches of difference across the entire area. Guys, I've been looking for that for the past 10 years. I've yet to find it that hasn't been paved and painted with stripes so you could park your car on it. We will continue to look for it, and if we find the situation, you can install it. If you think you've got it and you want to do it, give us a call up. Okay? Just realize though that that 4 inches, that's across the entire disposal field area, and I'm hesitant to say that you'll ever find it. We used to have a big problem with the aggregate that's used in the conventional systems. We have less problems today. Now guys, this is one of the two top things I hate telling you. I really do. I hate telling you that your rock is either A, too small, or B, too large, because that means y'all are going to have to shovel it all out. I really do not like telling y'all to do that because I know it's a chore. Therefore, make sure what you've got is the right thing before you ever put it in. The state regulations for this, we're the same, we should be the same as Sumner County, Dixon County, Rutherford, Robertson County, because this is strictly out of the state regulations. 90% of the stone must be able to pass through a 2.5 inch screen. That means that 2.5 inch, or 90% of that stone needs to be smaller than 2.5 inches. 5% can pass through a 1/2 inch screen. So only 5% of it can be smaller than a 1/2 inch. So you've got to have that range in between 2.5 and a 1/2 inch. Most common question I get from people, Chris, I'm talking to the rock quarry, what size rock do you want? I'm hesitant about telling y'all a size, because as soon as you order, I want 2.5 inch rock, you're going to get some 3.5 inch, you're going to get a little bit more 3 inch, you're going to get a whole lot of 2.5 inch rock, some 2, and a little bit less 1.5 inches. You're going to get a range in there. Okay? Therefore, if you ask me, if you call me up, say, Chris, what do I need to ask for? I quote these. Therefore, you're not at fault. If the rock quarry does not give you what you specify, then it's their fault. But if you call in there and say, hey, listen, I ordered 2.5 inch stone, it did not pass the inspector's review of it, well, that's kind of your fault, because they're going to feed you that lie, that it's going to be a range in there. Now, if you want to gamble and say, hey, I want an inch stone, realizing that you're going to get some 2, a little bit more 1.5 inches, a whole lot of inch, that's y'all's business. Ultimately, the responsibility is going to be yours. The aggregate should not contain an excess of fines, dirt, or dust. Therefore, when you get your load dropped onto the ground, realize that your rock's almost like a bag of potato chips. You know how all the crumbs and everything just kind of fall to the bottom of the bag? Same thing with the rock. Therefore, when you start scooping up your rock from that rock pile, try not to scrape the bottom of the pile unless you have to. If you have to, if you got to scrape the bottom, you're going to get the worst of that rock inside that system. Our preference is that goes on the bottom trench, not on your first trench. Not on the trench that's going to see the initial amount of sewage and the most sewage over the lifetime of the system. We much rather it go into that very last system. Aggregate cover on these systems, what I got shown here is the untreated building paper. By state regulations, you are allowed to use remade untreated building paper or 2 inches of straw. I really want to see y'all use 2 inches of straw at least once, preferably on Mr. Collins' inspection. But none of y'all will ever use straw because it's too expensive. You'll always use the untreated building paper or remade. Do not use the old asphalt paper. We will make you pull that up. Here's a little cross section of the aggregate. Before we mentioned, if you do not have a rock slide, you are responsible for putting in a 6-inch grade board. That's going to, commonly what's going to be used is a 1x6. grade board. A lot of guys call up and say, hey, listen, I'm getting a good price on 2x6s, can I use that? Hey, that's fine with me. What we're after is keeping that pipe 6 inches off of the bottom of the trench, okay? I really don't care about the width of it. I care about the height of it, which is 6 inches. You're going to be using a 4-inch black pipe. Your gravel, by state regulations, is required to come 2 inches past the top of that pipe. Now your crossover, and remember guys, earlier I said that crossover is 4 inches off the top of that pipe. Therefore, you're going to have only 2 inches between the invert of your crossover and the top of that gravel. That's an easy way for me to inspect it. When I go through there, I'm going to look, see if you got those 2 inches. And if you don't, either you probably don't have enough gravel, you got too much gravel, or you put that thing up too high. So keep that in mind. If you put too much gravel on there, it's going to have the fact that you've probably put that crossover in correctly. You just got too much gravel that needs to be raked on out. Total depth of your gravel is going to be 12 inches. That's simple. The 6 plus the 4 plus the 2 equals 12 inches of gravel. Now, it was asked in the previous seminar, so I'll kind of go over it now. Somebody asked a question about modified conventional systems. You don't see a lot of modified conventional systems. I dare say we probably do maybe 1 or 2 a year. The reason being is a lot of times when we can do a modified conventional, we could get in a traditional LPP. And we'll tend to go for that traditional LPP before we'll start modifying conventional. You can modify conventional systems in too numerous ways to even count. But a lot of it is concerning the amount of aggregate that you put in there, the amount of backfill that's going to be on top of that system. It can even concern the size of the grade board that's going to be put in there. We could require a 1x4 grade board, a 4-inch pipe, 1 inch of gravel on top of it, 10 inches of backfill over the top of it. Therefore, anytime we're going to have a modified conventional, it's going to be clearly stated on the plans. It's going to be clearly stated what you've got to do with it. If one comes across your desk before you bid on it, please give us a call so we're all on the same line here and you don't get horse bid after the fact. Again, we covered 1x6 grade boards are going to be used. I don't care how that pipe's affixed to that grade board. You know, I love dealing with this nature of the business. I like construction. I like you guys. Because I can take 5 of you and say, figure out the easiest way, the quickest way to do something. I'm going to get 4 different ways to do it. Same thing with this. You can use gutter nails nailed through the top of the pipe, splitting that grade board. You can sit there and set wood stakes on either side, holding your grade board up and holding your pipe on top. You can use cable ties. I don't care how it's affixed as long as it's affixed. As long as that when you put that gravel in, you don't knock that pipe over off the grade board. If you do that when I come through and I inspect it using my laser transit, we're going to have some problems with that pipe elevation. A lot of these guys, they actually construct their grade board and their pipe in the shop on rainy days. Therefore, when they got a job, they go out there with 10-foot sections. Again, that's fine with us. Disposal fill pipe must be 4-inch ABS and perforated with 1/2-inch holes. That's nothing new. Your tight line from the tank to the system, it must be constructed 4-inch Schedule 40 PVCs. Much like the crossovers, no 90-degree fittings. The only time you're going to have a 90-degree fitting on a conventional system is if it's pressurized, and that is only on the tight line. Other than that, if it's a gravity system, meaning you don't have a pump tank or a pump in it, do not use a 90-degree fitting. I don't care if it's the last fitting on your truck. Don't do it. If the system is pressurized, we'll be using a 2-inch PVC tight line. Crossovers, we've already kind of discussed that it's going to be 2 inches over the gravel media, 4 inches off the black pipe. But what we haven't talked about is when you construct a septic tank, or when you have your septic tank put in place, that the invert of the outlet of your septic tank to the invert of your first crossover, there needs to be 4 inches of elevation difference in between there. And whereas I hate telling you guys to remove rock from a trench, the number 2 thing I hate telling you guys is that you don't have that 4 inches of elevation difference. You've got your 4 inches off the black pipe with your crossover, so we can't manipulate that crossover. Therefore, you're going to have to drain your septic tank, call your septic tank, or call your tank guy up and have you move that septic tank up in elevation. But if you don't have that 4 inches of elevation difference, you don't have that wiggle in your first crossover, that's the only thing that we can do. Now, that 4 inches between the invert of the outlet of the septic tank and the invert of that first crossover, that also carries forward to switch boxes and baffle boxes. If you've got a pressurized system and you're shooting up to a baffle box, we still want you to have that 4 inches of elevation difference between the outlet inside that baffle box and the 4 inches of that first crossover. Large diameter gravelless pipe. We only allow the 10-inch LDGP pipe here in Davidson County. I'm aware that they make an 8-inch pipe. However, that 8-inch pipe does not equate to a 3-foot wide conventional system. Therefore, we do not allow it. Trench width is going to be 24 inches. Remember that you're going to be installing this on 8-foot centers with 6 feet in between your sidewalls. Because you're dealing with that 2-foot wide trench, that's where you're getting that 8 foot instead of the 9 foot that's required on the conventional system. Trench depth on a large diameter gravelless pipe will always, forevermore, write it down, be 2 inches per 100 feet. It does not matter if you have a 24 to 30 inch digging depth. It does not matter if you have a 24 to 36 inch digging depth. Because of the nature of the large diameter gravelless pipe, you will only be allowed to have the 2 inches per 100 feet. Where sand backfill is required, the sand should be level to the top of the pipe. It does not have to go over the top of the pipe. Sand in a large diameter gravelless pipe is going to be required in 75-minute soil and 60-minute soil. This is nothing that you have to have memorized. This is just for the sake of your knowledge. These are the heavier clay soils. Okay? It will always be mentioned on the plans. I just want to tell you though, the only time it's going to be required is when we're dealing with a 60-minute soil or a 75-minute soil rate. That is why on the repairs we don't use the conventional, because we usually don't know what the soil rating for that particular soil is. The sand that's going to be used in it needs to be medium grade sand. I can't tell you what the rest of it is. I don't even know if I can tell you what medium grade sand is. I can tell you though if it's free from silt and clay. So if we go out there, we're mainly going to be looking to make sure that that sand is clean sand. Medium grade, I'm going to kind of leave that up to you guys. Just make sure it's clean. Therefore, don't scrape the bottom of your kid's sandbox when you're stealing it in the middle of the night, okay? A little bit more care needs to be taken on the large diameter gravelless pipe when digging the trenches. They need to be kept clean. The whole reason that this system is capable of working without a gravel media is that little sock that goes around it. Therefore, when you're digging the trench, you need to try to remove any of the sharp rocks that are jutting out into the wall, and you need to prune any of the roots that may be coming out into it. For two reasons. One, when you shove that pipe in there, you can tear that fabric. Two, just to prevent any further damage from happening in a couple of years. The location stripe should always be face up. That's nothing new. That's on the conventional, on the 4-inch ABS pipe. Also, that's just to ensure proper location of the hole. It's not because it's pretty or anything. When we go out there to inspect it, we want to make sure that we can see that green stripe. When you're pushing that pipe down, if damage occurs, you need to repair it using duct tape. Okay? Don't just leave a hole there. Like I said, the whole reason for that system to work is because the bacteria is going to grow on the inside of that fabric and therefore treat the sewage before it's allowed to go into the soil. That fabric is replacing the rock media. If you leave gaps in it, if you rip a hole and you don't repair it, you're basically allowing that untreated sewage to go out into the trench wall, and that's where your bacteria is going to start growing on the trench wall, and therefore clog up that trench before it's time. In keeping with that thought, make sure that your filter wrap's tight and intact. The picture to your left shows a connection where two pipes have been joined. What the gentleman has opted to use, he has tucked his fabric into the saddle that has connected two pipes. The pictures on your right hand side show two different end caps. One gentleman has tucked the fabric into the solid end cap, which is actually all that's required. However, he went one step further and he put a roll of duct tape around it, just therefore securing that cap's not going to come off. Another gentleman, he extended the fabric past that end cap, put a twist tie over it, and is keeping it tight that way. All ways are approved. Again, we're keeping with the nature of the system that we want to keep that fabric tight and intact. We want to keep the sewage in to get treated. Inspection ports, they are required here in Davidson County. I always enjoy it when I get a gentleman from out of county calling up about wanting to put in a large diameter gravelless pipe system. And I had to tell him inspection ports are required. He know all about that, and his answer is going to be yeah, I know all about it. And then I just count the days until I go inspect it, because they will be sideways, they will be upside down, they will be backwards. First of all, if you're ever unsure about something, call us up. Okay, it's that simple. All inspection ports is a large T-fitting. You're going to have a bottom end that's going to be your sump. You're going to have a top piece that's going to have to extend to the ground surface. Now, to extend it to the ground surface, you need a solid piece of pipe, solid piece of 10-inch large diameter pipe to extend it to the ground surface. This is not like any of the other components that are required to extend 2 inches past grade. This only has to extend to the grade surface. If and when the homeowner or the general contractor come up to you and ask you to backfill over the inspection ports, feel free to tell them that grass will cover these up. There really is no need to put extra dirt on top of these. The grass will grow over them in time, okay? Your inspection ports, they are only required on one side of the trench, keep them all on one side. Therefore, if we happen to lose the drawing that indicates which side the inspection ports are put on, we can go out there and find them just a little bit easier as opposed to trying to find them on every other side. Okay? Remember to secure the fabric inside your inspection ports. The lower picture, just tuck the fabric right inside the inspection port. Doesn't require the duct tape that was shown in the earlier picture. It's nice and tight. Your crossovers on the large diameter gravelless pipe, you've basically got two on there. However, I've only seen one. You got a saddle tee and you got a pop-in tee. My guess is the saddle tee is expensive because, like I said, I've never seen it in the field. The only time I've seen it is when the distributor gave us a sample of it. Okay? Either one is okay with us. To construct a large diameter gravelless pipe crossover, a lot of similarities here between a conventional crossover. But you need your pipe, you need a cutting utensil, you need your 4-inch Schedule 40 PVC pipe, and you need your worm screw band. The first task, get your pipe. Cut your hole in it. Preferably, gentlemen, we would have cut an X into that fabric. Instead, we've gone ahead and we've cut a hole in there, and when we go ahead and we put in our pop-in tee, we're going to have some gaps in there that we're going to have to fix. If we had cut in an X, we would have just simply tucked in that fabric and the job would have been done. We go ahead, we pop in our pop-in tee. There's it from the side. You can see the gaps that I was talking about earlier. We've also managed to find a rip up there. All this is going to have to be fixed using the duct tape. Much like the conventional crossover, I've got my short section of PVC coming out of that pop-in tee before I go into my elbow. And I've got it angling down. I tighten it using my worm screw band. I finished the job by putting duct tape on and securing all those rips and tears and gaps. In recap, guys, on non-alternative soil absorption fields, you got two main systems that we talk about. However, we do have chambers starting to make an entrance here, thanks to this man right there. But your two main systems, you got conventional and large diameter gravelless pipe. Your conventional, you're dealing with the 3-foot wide trench. Your large diameter, you're dealing with the 2-foot wide trench. On the conventional, you can have up to 4 inches of elevation difference. Up to 4 inches, okay? Remember, on that 24 to 24, regardless of what system type, it's going to be 2 inches per 100 feet, okay? Now, large diameter gravelless pipe, regardless of your digging depth, you're always going to have 2 inches per 100 feet, okay? Your conventional system, it will require rock, it will require grade board unless you have a manufactured rock slide, and you will require to have a media cover, being the ream-A, untreated building paper, or 2 inches of straw. The large diameter gravelless pipe here in Davidson County, we will require the inspection ports on it, and it may require sand. I want you guys to remember that 4 inches of fall in between the invert of the outlet tee in the septic tank or baffle box and the invert of the first crossover. I can't tell you how important that is, guys. Second, PVC crossovers going to be held in place by stainless steel worm screw bands. And your elevation difference, the 2 inches to 4 inches, always going to be per 100 feet. Therefore, if you put in a 50-foot trench, that 4 inches becomes 2. That 2 inches becomes 1.
My name's Scott Loth. We're going to vary again from the schedule just a little bit. I believe the schedule said we were going to do locator wire next. But since Chris was talking about some of the different systems, I'm going to go over, briefly cover chamber systems, and then go over the locator wire. Typically in the past, we've just mentioned that chamber systems were allowed in Davidson County, and then if you had any questions about putting one in or were thinking about it, to just give us a call and we'd go over with you one-on-one. This past year, my understanding, the price of rock has gone up, and it's getting to the point where it's going to kind of offset the cost to put in a chamber system, and we've had several inquiries and actually had some put in this past year, so we thought we'd go a little bit more in depth on the installation. So we're going to briefly cover a little bit on the chamber system here in Davidson County. The site and soil requirements for the chamber system, a lot of these requirements are going to be the same as a conventional system or the large diameter gravelless pipe. The area of suitable soil that's required for a chamber system that's going to be available has to be equivalent in size to that necessary to install and duplicate a conventional or large diameter gravelless pipe subsurface sewage disposal system. So it's just going to be the same. It requires the same amount of soil, same soil types as your conventional and your large diameter gravelless pipe. The layout of the system in Davidson County, now other counties I believe offer a reduction in size if you use a chamber system instead of a conventional or a large diameter gravelless pipe. In Davidson County, we at this point do not allow that reduction size. The size of the chamber system has to be equivalent to the total linear footage required for a conventional or large diameter gravelless sewage disposal system. The lateral lines shall be placed on contour. The maximum length of a single line should not exceed 100 feet. That's the same as the conventional large diameter gravelless pipe. The trench bottom of each lateral should have a grade from level no greater than 2 inches per 100 feet. Chris just went over that in detail. This here is the same as a large diameter gravelless pipe system. It's 2 inches per 100 feet, not the conventional system, which can be up to 4 inches. And we always recommend that you install these chamber systems according to the manufacturer's specifications. As you can see in the picture here, here's one that was installed just a little over a month ago, and still requires a minimum of 6 feet undisturbed earth in between the adjacent trench walls. Okay. And the trench width on a chamber system is to be 36 inches, and on this particular system it was 36 inches deep. But it's just like a conventional and large diameter gravelless pipe. It can be anywhere from 24 to 36 inches. Just depends on what our specifications recommend. So always look at your recommendation sheet that we send to you. This here is for the upcoming locator wire. If you'll notice there that the locator wire was put into the sidewall and grounded properly there. I just thought I'd show that to you. All right, next slide. Now, the top of the chamber system is required to be below the invert of the septic tank outlet. Go ahead and click. Got my little arrow there. But the top of the chamber down here at the bottom of the slide has to be below the invert up there coming out of the septic tank. The trench for the crossover, where it connects to the preceding absorption trench, shall be dug no deeper than the invert of the opening and the end plate. Go ahead and click it there. As you can see there, the bottom of that trench for that crossover is higher than where it goes into the next trench. Okay. And the chamber sidewalls must be designed to allow effluent to pass laterally into the soil. As you can see by my arrow there, there's little slits in the sidewalls. So any chamber system that you get have to have those slits in them. That allows the effluent to get into the sidewalls there. Right now, this is from the memo that I have right now. There may be more systems that have been approved by the state, but this is the one that I have at my desk right now. Right now they have 4 different companies, and each company has one that the state has approved. So if you're thinking about putting one in, give us a call. If it's not one of those 4, we'll talk with you and the state and see if they've got an updated list. Like I said, when we send out a recommendation form, right now it's going to say large diameter gravelless pipe or conventional. We're not going to put on there a chamber system at this time, but if you think you want to put a chamber system in, just give us a call and we'll talk to you more about it. And that's pretty much all we're going to do right now, just kind of a brief synopsis of a chamber system. Are there any questions? Yeah.
That crossover point in the end instead of 10 foot from the end, is that the way they're made?
Yeah, I believe they can go either way. I believe they can go in the top, but the state, I believe, recommends that they go from end to end. Yeah. Any other questions?
Scott, repeat that question so we get on tape.
Oh, I'm sorry. His question was that he noticed that the crossover was coming into the end of the next trench, and typically we require that they come in to the trench. They come out of the upper trench 10 feet over down into the next trench. But my understanding on the chamber system is that the state allows the crossovers to go from end to end on a chamber system. Any other questions?
Less soil types for the chamber.
It's the exact same as conventional and large diameter gravelless pipe. My understanding is they don't require sand backfill if it's over 60 minutes, where a large diameter gravelless pipe does. But a lot of the regulations are the exact same. We just kind of hit some of the ones that are a little bit different. Any other questions?
If you want to ask Ricky over here, they installed that system, and I inspected it about a month ago, so if you ever have questions, I guess about what they go through to supplies and costs, what you might want to just run by him. After having a little break, interested in putting it in.
Yeah, my understanding is it's almost like putting a puzzle together, come in about 5-foot sections. They kind of clip together. And as far as going around curves, following the contour, they've got little wedge pieces, kind of like the shape of a piece of pie, and you can stick those in just like a piece of puzzle, go around curves. So, all right. That concludes the talk about chamber systems. We'll move on to a brief discussion about locator wire. Here in Davidson County, we do require locator wire to be installed on all new installations. Keyword, new installations. The locator wire must be insulated 12 or 14 gauge single strand copper wire. It needs to be secured by a hole being drilled into the riser of the septic tank or the pump tank, and the wire being secured in the tank. We also require waterproof connectors. As you're putting the wire in the system, when you come to a spot where you got to splice stuff together, we require waterproof connectors at all those spots. The installation, the wires to be fixed to the inside of the septic tank. Also the wires to be located in the center of the trench and affixed to the tight lines and crossovers. And every free end should be properly grounded. That goes back to that picture I showed you in the previous slideshow, where the free end was grounded by sticking it into the sidewall. You need to strip the end of the wire about 5 inches and stick it into the sidewall.
Good morning. I'm Walter Collins, and I'm going to talk to you about the pressurized distribution conventional system. By the term pressurized, you can guess there's a pump involved here. And what we're trying to do is create a system, and we have created a system that we can use in certain specialized situations that will be better than just a pump system feeding a conventional system, and it will be better than a conventional system with crossover pipes. The advantages of this system are that by dosing it through a pump in a pump chamber, it allows the system to rest throughout periods of the day, and that increases the system life. It allows equalized and simultaneous flow to all the absorption field trenches. Now, by doing that, we overcome a lot of the problems with a conventional system using crossovers, in that first trench with a crossover pipe and two, those systems that are served by a pump, that first trench is often overused. And this way, it's sort of like a low pressure pipe system in that we can allow simultaneous use of all the trenches at one time. It can also serve installation areas of complex topography, where you have an installation area that undulates, or where you have a ridge line that you want to install absorption fields on both sides, rather than depend on crossover pipes to serve complex situations like that. We can dose it through this system here to all the trenches at one time. All the trenches are pressurized at the same head pressure, and we'll get equal flow to all the trenches, and regardless of the trench depth and its elevation. Jesse? The disadvantages are that it's more expensive to install due to the use of the valves in the pump tank, and there's a slight increase in installation time because you're drilling holes in an orifice, and we'll talk about the complexity of that situation in just a little bit. And also, once it's installed, it's going to require a little bit more maintenance. It's sort of like a low pressure pipe system, in that you do have some stoppage of valves on occasions. You have to clean the system out and flush it out to prevent accumulations of sludge. We're going to say that we want the homeowner to keep the tank pumped on a more frequent basis, usually 2 to 3 years on these systems. Jesse? And again, you'll see it where we're wanting a large system to be installed, instead of having a multitude of crossover serving a multitude of trenches, we can give this system a distribution through these discharge pipes that we install with valves, and we can bring flow to the entire system at one time. And it won't matter at all how many trenches we install in these systems. In situations, again, of uneven topography, it's a great advantage. And we had a situation a couple of years ago where we had a hillside, and we wanted to install trenches on one side of the hill and on the other. And we were able to do that through a manifold that dropped off to one side of the hill and to the other, and we fed them simultaneously, and it worked out great. And when the absorption field may need to be installed in split areas where you've got a part of the absorption field in one part of the lot and part of it the other, well, you can understand with a conventional system with crossover pipes, you're not going to be able to attain that. But we can feed it through this pressurized system, and again, we can service both areas simultaneously and divide the flow equally into all the trenches. Now, if you need to install one of these systems, and we realize that there's not a great demand to install them in Davidson County. In fact, we've only installed 2 or 3 since we started using them. And we know that if we tell you today about how to install them, that by the end of the year or perhaps next year, when you're faced with the installation of one of the systems, that you're going to forget. So what we're saying to you is that we're going to be here for you, and when you find yourself in a situation where you're about to install one, you'll get back in touch with us. But essentially, you'll obtain a permit just like any other conventional system, but you will contact us, call us, and make arrangements for us to meet you on site. And we'll discuss the situation and familiarize you with the concepts of installing it and what you need to do before you actually get into the process. And once you've installed the system, then you'll obtain the installation inspections as necessary. And there may be more than one. I'm going to talk to you generally about what the system consists of. The components are generally a manifold pipe which comes from the pump, and it serves these laterals that are installed just like a conventional system. There'll be a regular conventional system with a grade board. You'll have ABS pipe, and you'll have an end cap in which is drilled a hole, and you'll use a hole saw to cut that hole, and it will be cut large enough to accommodate an end cap that's also drilled with an orifice. Now, this orifice is sized and has to be drilled very carefully. And our plans will tell you that you use a certain diameter for a certain length of trench. The longer the trench, the larger diameter this orifice will be. And I'm stressing to you that the drilling of this hole is crucial, in that if you drill it haphazardly, you may drill it too large, and that trench will get too much sewage. The pressure adjustment on the trench to set the head pressure is achieved with a standpipe, and that's much like a low pressure pipe system, in that standpipe is originally set at 3 feet, and you adjust the valve to allow the sewage to come up to a certain level, which is 3 feet, and it'll bubble over. And once you achieve this head pressure, you can stop adjusting your valve. Now, of course, when the system's installed and your head pressure is set, You will cut this at ground surface and install a male fitting with a female galvanized cap. Now, these valves are bronze or they may be PVC. And what we're asking is, when you install the system, this charge pipe that you see here, and it's usually 1 inch in diameter, it should be left unattached. And the reasoning for that, when we're in the inspection process, we're going to pick up this charge pipe during the inspection and make sure that the orifice is drilled correctly to match the length of the trench. You then will be able to glue that back on once you set that into your ABS pipe and the system be ready to work. But that's essentially it. And again, we're asking you not to install it without getting us out there to familiarize you with the installation procedure. But here you see one that incidentally Ronnie Gossett was associated with. He's in the audience with us today. But this was one of the first ones that we installed here in the county, and that shows the pressure stand pipe that you use to adjust the pressure, set at 3 feet. And of course the valve is manipulated once the pump is actuated to attain that 3-foot level in the standpipe. And by doing so, we get an equalized pressure across the system. Jesse? And this shows a valve box here that protects that valve. And it's a 6-inch ABS pipe and with a cap on it. And it also shows the manifold that's already serviced one of the laterals, and it comes up and terminates with a clean out. And again, that standpipe is still at the 36-inch level and hasn't been cut to grade at that point in time. Jesse? This shows the inspection process. We're assuring that orifice is drilled at the correct diameter. We'll carry a set of bits and determine that on site. Jesse? The inspections that you will have will require you to have all the components installed and ready. The pump tank needs to be half full of clear water. That's necessary because we're going to set the head pressure on that system with the water in that pump tank. You'll leave that PVC piping cap with the drilled hole, that's the charge pipe, unglued so that we can check that hole diameter. And once inspected, you can insert that piping cap into the ABS pipe and glue it up. And you of course, you set that head pressure by activating the pump, and then we'll go about our business and check the system like we normally do. And after we leave, you of course backfill that and cut that standpipe down to the ground surface and install the galvanized pipe. But that's essentially it. Any questions about the system? Again, I'm Walter Collins, going to talk to you about the low pressure pipe system, get you certified for that type of installation. The low pressure pipe system is a pressurized distribution system. Again, we're using a pump for subsurface sewage disposal. The major components are a series of laterals that we'll install, the septic tank, the pump and pump tank, and a high water alarm and float. We installed the LPP systems, excuse me, rather than a conventional system to, one, conserve space when the area of suitable soil that would been defined by the soil scientist is limited. And secondly, there are some situations where the soil factors are not suitable to support a conventional system. That might include soil depth, and it might have to do with permeability. But in some cases, we can use that LPP rather than a conventional system to allow a residence to be built. The advantages of an LPP system is that it might be installed at a shallow depth where permeability and aerobic activity is best. That's an oxygenated zone where aerobic activity flourishes, and the system will work better in that zone. You also get uniform distribution. We talked about that with the conventional system, that distribution type method. And uniform distribution throughout the entire system will lead to longer life. And it also uses dosing and resting cycles, and we talked about that. That's going to enhance aerobic activity, and it'll allow for the system to last longer. The disadvantages of the LPP is that it has a higher initial cost to the homeowner. The extra time that it takes to install it, the extra care that it takes, the pump and associated hardware will cost more. You'll also have increased maintenance and adjustments to the system throughout its life, and that leads to additional cost to the homeowner, and that has to be considered a disadvantage. It requires your pump system, and there are times that pump's going to go out, and just the installation of that extra equipment costs more, and it's a little bit harder to install. A little bit more care needs to go into it. And I think all of you who have installed them in the past know that. The steps of installing the system is first to assess the soil moisture. That may be important with an LPP than any other system. If it's at least bit damp, you run the risk of smearing the sidewalls of the trenches. So we ask that you come see us if you have any doubts about the soil moisture content, and we'll make a determination whether or not it's sufficiently dry to proceed. We need to watch for disturbances. No cut and fill within 25 feet of the installation area. We want to make sure that all grid stakes on the plan are in place, and if they're not, you're going to come see us or contact the homeowner, but preferably come see us. Let us take the burden of getting with the homeowner, get those grid stakes replaced. But you'll lay out the laterals, and in doing so, you may see remnants of wire flags that were left by our office officials as we go out to each and every site and lay out these laterals, and we show them to scale on this plan that you're going to get. Now that plan, most likely you'll see a 1 to 20 blow up of the installation area showing the lateral locations, the valve placements, etc., the manifold. And we caution you about these wire flags that are in the field on the ground. We've had situations where perhaps children or homeowners have displaced those flags and moved them. So you need to reshoot them. Obviously, there's a good chance that they're in the right location, and they will guide you to some extent in where to start and finish the laterals, but there's that chance that they're out of place, and if they are, that could you run the risk of installing the laterals improperly. So shoot them and compare them with the plan that we're going to give you to make sure that they're accurate. And once laid out, you can trench and lay out the pump line and manifold. You can excavate the lateral lines, keeping the trench bottom level. Unlike a conventional system, we say that we want the LPP system trenches to be dead level. You know, we may be going too far to say dead level, but we're not giving you a tolerance like we do in conventional systems. You will assemble the lateral pipes and drill and mark the holes, place the pipe into the trenches on supports, and we'll talk about the supports later on down the line. You'll install the valves, turn up pipes on the laterals, and connect the assembled lateral to the manifold. You'll set the septic tanks and pump tanks, and we set them last so that you can make sure about the elevations and what have you. But install the pump and alarm floats, adjust the pump float to achieve a proper dose to the system. And again, if you're pumping downhill, it's important to drill that anti-siphon hole to prevent siphonage of the sewage into the system once the pump is turned off by the floats. You will pressure test that system, and we'll be there. The health department will assist you in pressure testing the system and adjusting the valves to 3 feet ahead. You do that at a turn-up pipe, and it's important for you to have enough help on site in setting these head pressures that we can adjust the valves, and you'll find that in adjusting the valves to achieve a certain head pressure, that if you adjust one valve, it affects the pressure on the adjacent laterals, and you'll go back and forth to achieve a perfect 3 foot of head. And in doing so, you'll need several people there. Sometimes it's nice to have a person on every 1 or 2 laterals. And if not, you're running back and forth, and you exhaust the water in the pump tank that's used to set these head pressures. Well, once the head pressure is set, you can cut the turnups at the surface. The turnup pipes, again, the pipes that are used to achieve the 3 feet of head. And you'll install the end caps, and they're metal galvanized caps. You add 9-inch layer of proper aggregate to the trench, which is 6 inches beneath the pipe. You cover the gravel with building paper, untreated building paper or remade, and then carefully backfill the trenches and finish and seed. Now there are situations where the soil will not accommodate a standard low pressure pipe system and will require modification by adding a layer of supplemental soil over the original soil. And we will show that on the plan. Now, our plan will reveal to you that we want you to add that supplemental soil even beyond the installation site by several feet, and then taper it off. And that layer is usually 8 inches in depth, and it will settle down to 6 inches. And 6 inches is what we're looking for after settling and compacting. We want that layer to be at least 6 inches, and we want it consistently applied, meaning that you need to have a consistent 6 inches or 8 inches originally, and you want to, when it sells, you want 6. To do this, to apply this supplemental soil, we will want you to remove the vegetation from the installation site. And when we say remove the vegetation, if it's leaves, we rake them off. But if it's grass, you have to approach that carefully, because obviously you're going to have to scrape that grass from the installation area, and we don't want you to remove any of the topsoil. And that's hard to accomplish, but I think what we're trying to convey to you is that when you get done, we want to look at the installation area for your LPP and see sprigs of grass still remaining. In other words, you don't have to get every bit of the vegetation. We have had situations where people have come in and scraped the grass from a site, taking a couple of inches of topsoil, and you look at the pile of vegetation, and it's pretty much all dirt, or at least 2/3 of it may be dirt, the rest of it grass. So those situations make us pull our hair, and we want to avoid that, and I haven't got that much left. So be guarded of that original soil layer, and not scrape that from the site when you remove your vegetation. Once it's removed, we want you to scarify the area with what's called a chisel plow. And a chisel plow has tines that dig down into the soil, and we want you to dig down as deep as 4 or 5 inches. And we want that soil plowed on the contour, or parallel with the contour, not up and down the hill, which would be perpendicular to the contour. We want it plowed around a hillside, staying on contour. Now, if you don't have a chisel plow, I think an acceptable alternative would be a box scraper with ripping tines. If that box scraper is set to an angle where it will rip and not take any soil away from the installation site. So you have your choice, but the best situation would be to find a chisel plow and pull it with a tractor. Now, around trees, you scarify that area perhaps with a tiller. Now, if it's all trees and you can't get into the site with a chisel plow or a tractor, you may be able to use teeth on a backhoe, but that's the last. I mean, that isn't recommended, but we have had it successfully done if you got good long teeth on your backhoe bucket. The soil that we're looking to apply over the installation area has to be approved by the soil scientist, and you just can't use any type of soil. We're looking for compatible soil, topsoil type grade, to apply over that area. So bear in mind that the health department has to approve the topsoil, and it's best for us to look at it before it's harvested, before it's gathered and brought onto the site, and that way you know that it's acceptable even before you even dig it. So you have to call and arrange for the soil scientist to look at that soil prior to gathering it. But once it's there, you pile that cover material around the installation site, and that's already been scarified, and then you'll work it back onto the site without driving over the scarified soil. You'll work it back over the installation area. And again, we're looking for a 6-inch layer after it settles. So again, apply approximately 8 inches. And you might do that with a series of grade stakes. That might be the best way to make sure you get a consistent application, is to erect grade stakes, maybe on 25-foot intervals. And then once we approve the installation of that supplemental soil, then you can get on with the standard LPP installation. This slide here shows the manifold pipe, and a note that says, when pumping uphill, the manifold shall be extended above the uppermost lateral and then turned back downhill to serve the highest lateral first. And that's important. And the reason it's important is that if that pump should fail, or that pump impeller wear to the point that it doesn't make the trip to the highest lateral, we're going to know it. That sewage is going to build up in that pump, and the alarm's going to go on. But if you serve the lower laterals first, that pump may pump to the lower lateral or 2 or 3 laterals and never get to the highest lateral. So we're asking that you install that manifold all the way up the hill and turn down and catch the highest lateral first. And the end of the manifold, oh, and by the way, install that manifold to drain when the pump goes off. So essentially that manifold may be an inch or so above the laterals in the trench, to where when the pump goes off, it'll drain into the laterals. We won't have an issue with freezing, because again, this system's installed at a maximum depth of 18 inches, so the manifold very well could be more shallow than that. The end of the manifold at the lowest elevation must terminate with a clean-out plug, as you see in the picture. This next slide shows the proper installation of the pump line. This situation demonstrates pumping uphill, where you do run the pump line up parallel with the system to the highest elevation and then come back down. You see the valves and the lateral pipes and the turnups on the end. Now this varies from the conventional pressurized system, in that the turnup is on the end rather than near the valves that we demonstrated earlier. Okay. Now, excavating the lateral trenches, you lay out and excavate the laterals on contour. And this shows a situation where they're excavated, and you excavate them 12 inches wide, and you excavate them 18 to 20 inches deep. Now, I would recommend that you install them at 18 inches. Now, there's situations where the ground undulates some, and you may have a high area that may be approximately 22 inches where your trench is dug through, and that variance in trench depth will allow for that. So find your lowest point on that lateral and dig that 18 inches, and the highest point would mean that your trench depth at that point might be 22 inches. The laterals should be a minimum of 6 feet apart. 6 feet on center is what we're talking about here. And with a 12-inch lateral, that would mean that you've got 5 feet of undisturbed soil between the trenches, between the sidewalls of the upper and lower trenches. Now, between the point where you dig the manifold and you start the 18-inch deep lateral trench, there'll be a dam of soil between the manifold and the starting of the gravel, and that'll be a point that you'll install the valve. Now, that dam needs to be 6 inches above the bottom of the trench. Okay. This slide shows a detail of the valve, the lateral piping, and the manifold, where you see the manifold. Now, normally the manifold on a low pressure pipe system is 2 inches, but there is that possibility that we're pumping a long distance. We got some friction loss in the line, so it may be that we increase the size of that manifold to accommodate that. So you want to be cognizant of the fact that manifold is not necessarily 2 inches. So you look to your plan, your specification sheet, to see what diameter manifold that we're using. Of course, where you branch off to your laterals, you'll use a reducer there. And the lateral pipe diameter is dictated by the length of the lateral trenches. And the longer the length, the larger the diameter of the laterals. The smallest diameter that you'll encounter will be 1 inch. And we have had situations where you'll see 1.5 inch diameter lateral, and that may be about the largest diameter that you'll encounter. We use gate and globe valves, and they are sized the same as the diameter of the pipe. Now these gate and globe valves are made out of bronze or PVC, not brass. Now a gate and globe valve that you see here is used to adjust the head pressure on that system. And there are situations where we like to segregate the laterals during the maintenance procedure and flush a valve, a lateral one at a time, and the valves then are useful in cutting off other laterals. So that's a use for those valves. And also, if we encounter a system where one trench in particular is failing after a few years, we may elect to cut that trench off completely, and the valve is useful in that regard. This is a side view of the lateral trench showing the manifold pipe, the valve, the lateral pipe itself, and a turn-up pipe at the end. Now this pipe here, this is on an installed trench where we finished the adjustment process. It's been cut off at the ground surface, and it's been kept with a galvanized female cap. And you can see the aggregate in place. There's 9 inches of aggregate, and the building paper or remade is applied over the aggregate just as you would in a conventional system. In that lateral, on the bottom of the lateral pipe itself, we drill holes, little orifices. Now they are normally 5/32, but depending on the plan, they may be as big as 7/32 of an inch. The location of those holes need to be marked on top of the pipe, and you'd use a magic marker to do that. And we'll learn later that the distance between those holes is normally 5 feet. That's the typical hole spacing that you'll encounter. Now that may vary, so you need to be guarded of that. The plan will tell you about that. We start the first hole 30 inches, 2'6" from the valve, as you can see demonstrated here. You have 5 foot typical hole spacing, and the last hole will be 2'6" or 30 inches from the end of the trench. So you can see here that our trenches that you see on our plans out of Davidson County will be in increments of 5 feet. In other words, you won't find a 53-foot lateral, you'll find a 55 or a 50. And we'll have a chart on the plan that will tell you about the length of each lateral, the diameter, and the number of holes. And again, the lateral length dictates the lateral diameter. Pipes are supported in the trench in several ways. You can use bricks or blocks to support the pipes, or you may just simply add a pile of gravel ever so often. And that's what's shown in this particular demonstration here. If you elect to use gravel, you want to make sure that it doesn't occur in an area of the lateral where there's a hole drilled. We want to, when we do the pressure test, we want to see flow coming from each and every hole. And if you block that with gravel, we're not going to be able to see that. Now, one of the advantages of using gravel is that if you get a section of the pipe too high, you can take a hoe or another instrument and just rake some gravel off and reset the pipe and adjust the elevation of it that way to get it level. But again, the trench bottom is important, as the trench bottom needs to be level also. And we encourage you to look at the lateral as you're putting these supports in place to make sure that it doesn't flex or droop in spots. We don't want that to occur. This shows a bronze valve here, and PVC is also acceptable, but not brass. Valve boxes, essentially we will accept two situations. One is you can buy a commercial valve box like you see here and install that over the pipe, and they come equipped with a little mouse hole that straddles the lateral pipe and protects the valve. We'll also let you use a 6-inch diameter ABS corrugated pipe cut with a little mouse hole on each end to straddle that lateral, and then put an end cap on it, and that will suffice. That's a detail of it. That shows the ABS with the mouse hole cut. It also shows a plastic lid that needs to extend to the ground surface. Okay. On the other end of the lateral, you will find that turnip pipe, and originally we talked about that turnip pipe needs to be set at 36 inches from the bottom of the lateral pipe. You see we use an elbow, a PVC male thread adapter, and then a galvanized metal cap to complete the installation. Of course, you don't put that cap and that adapter on until the head pressure's been set and everything checked. The turnip pipe, initially the turnip is installed and cut back so as to be 36 inches above the lateral invert. After the head pressure is cut at the ground surface, and adapter and cap will be installed. And that's a nice picture of a turnip pipe ready for the pressure to be set on it. Okay. Proper aggregate is very important. We indicate that you need to have aggregate 1/2 to 1 inch in size. Again, we're hesitant to say use 3/4 stone. We've had situations where that just didn't work out, and the quarry sent smaller stones in some situations. So crawl up in the truck, if nothing else, and make sure that the stone is in the 1/2 inch to 1 inch range. Be also sure that it's washed and free of fines and sediment, because we won't clean gravel in the LPP. And that's different than in a conventional, although you won't clean gravel with a conventional, we ask that it be washed by an LPP. Okay? Tracer wire. We'll want that tracer wire to run just like on a conventional system, and you'll run it from the riser of the pump tank along the manifold to the clean out. Now, you install wires down each lateral, wrapping around the valve and the turnip pipe, keep it in place. And you ground the end wall beyond the turnip. You'll tie in those lateral wires to the main wire using waterproof wire nuts. Now, when we get ready to pressure test this system, the pump and floats need to be installed in the pump tank, and a pump connected to a permanent temporary power supply. We've had times that we've used a generator to do this. Sufficient water in the pump tank to do the test. And again, you at least need half full, and it may be that you need a full tank of water to do that if we're talking about several laterals. 3-foot turnips in place on each lateral, and each hole marked with a magic marker on top of the lateral. Holes clear of support and adequate personnel to be on hand where we don't have to run up and down the manifold like a Chinese fire grip drill. Once you call for an inspection with a soil modification, a modified LPP, there are several inspections. We have to check the field material, like I said before, by the soil scientist. We have to inspect the scarification of the installation site, and then once the fill material has been applied, we have to come back out and look at it. Now, the initial inspection of the LPP system itself, we inspect the septic tank, pump tank, and floats and associated piping, the supply line, and the manifold, the laterals, the piping and valves, and then we adjust the head pressure on the laterals. The final inspection, that's after we get the piping in place and we're sure that we've got an even 3 feet ahead. We inspect the gravel application, 9 inches of gravel. We inspect the remade paper over that gravel, and we inspect the application of the locator wire. And turnups need to be capped at this point in time at the ground surface, and any valve boxes, alarms, etc., and tank risers, we make sure that all of that is in place. Now, low pressure pipe systems require some maintenance from time to time, and we've talked about that with any of these systems we like to keep the tank pumped every 2 to 3 years. And the reasoning behind that is that sludge from the septic tank escape through the pump tank and present itself at the LPP system, and it does on a conventional system also, but with an LPP system, because we're at such a low pressure that we've turned these valves down to where there's nothing more than a little slim moon-shaped crescent that allows sewage flow to go through. And that moon-shaped crescent is not large enough that some solids can get through, and they accumulate on the pump side of the valve. And from time to time, they accumulate in to such a degree that the pump cannot satisfy its dose and runs continually, and it can run a pump to the point of failure. So we've got a way of addressing this. We're not sure that it completely addresses it, but we're hoping that what we're recommending here is satisfactory to solve these maintenance problems. But we pump the septic tank every 2 or 3 years and clean the filter, and we want lateral maintenance every 5 to 6 years on the system. Now, by lateral maintenance, we're talking about getting rid of this clog that occurs at the orifice. Now, I don't think we're experiencing great problems with the little holes in the laterals stopping up as much as we are problems around the orifices of the valves. And the reasoning that I'm thinking that the valves is the problem rather than clogging of the holes in the laterals is that I think we're making some mistakes with the installation of this system. I think sometimes we're sizing the sewage lift pump too large. To be on the safe side, we do that. But when you do that, you turn the valve down to such a point that it only achieves that 3 feet of head, and you further reduced the size of that moon-shaped crescent that's in that valve, at that gate valve. So as a result, when you reduce the size of that crescent, you get more clogging there. So I would stress that you need to look at the pump specs and buy a pump minimally sized to meet those specifications, and not buy one that's too large. And that'll save the homeowner money, or it may save you money. The steps of doing a maintenance function is first, do not go out and when you're on site with a homeowner discussing the problem, don't go and start adjusting valves and what have you, but rather if you encounter a situation where the pump's running and you're not getting any flow to the system, let's assume that it's a maintenance problem. We need to do something. Get us out there so that we can see what goes on when we do start adjusting valves. We can tell a whole lot about how that system's operating. So get a range of time for us to be on site with you I use the term supervise the procedure, but more or less just to witness the procedure. And we can supply you with copies of as-built drawings, or perhaps the owner can, or maybe even the Metropolitan Codes Administration. But with these as-built drawings, you can determine where the ends of the laterals are so that you can uncover the caps and get at them. Now, when we're out there, we will hope that you've got these caps already available for us to take off and watch and see about the solids coming out of that particular lateral. So having the lateral caps uncovered is very important at the turn-ups. And obviously the valve need to be accessible too. So you'll locate all that prior to getting with us, or at least prior to us being out there. And you'll need to have a way of extending those turn-ups up to 36 inches, because we're going to have to set the head pressure on that system if we muck it with the valve adjustments. So we'll uncap the manifold clean out, and in doing so, we're going to supply a way of that draining away from the system so it doesn't sit there and pool. And we're going to we'll want to pump the septic tank and pump tank and clean the effluent filter. And that's done before we get out there. And you'll disconnect power from the pump and fill that pump tank up with clear water. And that clear water is going to be used to flush the system and to set the head pressure on it. So when we're on site, we'll make sure all the valves are closed, and we'll activate the pump to flush out the manifold first until it runs clear. Then we're going to recap the manifold and open the valve on the highest lateral first and flush it through turning the pump on, and we'll run it till it's clear. Now, who's been out to an LPP to do some of these maintenance type procedures? If you have, you'll notice that when you open these laterals, there'll be a snake of black scum that'll come out, and they'll run for a second or two. Real heavy. I mean, they'll be as black as it can be.
Roots find them too.
Say it again.
The roots find them too.
Yeah, that's true too. Yes. So we'll run that for approximately 3 minutes to flush that through, and then we'll uncap it and. We'll cap it first and run it for 3 minutes, and that's flushing through the holes then. Okay, and trying to clear any solids accumulated in the holes. And then you uncap and clean out and close the valve. Each one of these laterals need to be treated in that manner by first flushing it out through the turn-up pipe, and then closing the turn-up pipe and flushing out the holes. And so you'll be keeping all the laterals off except for the one that you'll be working with. Now, once you finish the water flush, you can use compressed air to flush the system. And the way that you would do that is you would manufacture, you take a cap the same size as your turnip cap, and you will drill it and tap it and then insert a quick disconnect air compressor fitting. And you'll put 100 or more pounds of pressure into that lateral and force what sludge might be accumulated around each one of the little orifices out. And I think we've had better luck flushing them with compressed air, but it's important to do it first with the water and get the major part flushed out of the lateral itself. But again, it's the same process. You close all the laterals, you open one and flush it, and you close it down, you open another and flush it with the compressed air. So once we get it flushed out with water and air, we set the head pressure again on all the laterals. And when I say here, this last step, test the system for proper operation, I guess what I mean by that is that we can actually set the pump float to come on, and we can time the dose from the pump on to the pump off setting. And we can also measure from the point that the pump comes on to the point that the pump goes off, and determine the amount of gallons that's been pumped and the number of minutes that it took to pump it, and we can determine whether or not that maintenance procedure was acceptable in clearing all the orifices in the laterals. So we can, by knowing the number of gallons per minute that pump is pumping, we can make some determination of how effective our maintenance was. So I guess that's it in a nutshell.